Okay. Um, okay. You see my screen?
Yes.
Okay, great. Okay, so today we'll be talking about Linux. Maybe you've heard of this, but this is basically the command line, is what we use to get around the cluster. And so, what is Linux? It's an open source operating system, right? It's free. Anybody can download it. It's based off the original Unix operating system back in the 70s. And so it's technically a kernel which links your hardware, like your CPU, to the software and to applications. It comes in several flavors or distributions: Fedora, Debian, Ubuntu. And so you need to use a command line interface to, type your commands and execute them. There are some distributions that have graphical user interfaces or GUIs, such as Linux Mint, that are a little easier to use, and they look similar to, your normal operating systems like Windows. And, and so the shell is the actual program that mediates the transfer of your commands to the operating system for execution. The most popular shell is the born again shell or bash, and it comes with most Linux distributions. This shell is accessed via the terminal emulator, which is actually, a window. And a lot of people use the terms terminal and shell interchangeably. So, don't get mixed up by that. And so it has its own syntax with commands to edit files, variables, move, copy, stuff like that. And so the shell prompt is the $ in bash. And, whenever you see that prompt, that means you can um, insert commands and execute them. So a secure shell is how we remotely access another computer, typically a cluster or a server. On Windows operating system, you need a client to do this, such as MobaXterm or PuTTY. Those are probably the two most popular ones. And Mac actually has a built-in client called Terminal, which if you just search for it, you should be able to find it if you have a Mac. And so the thing about Secure Shell, it's has public key cryptography for a secure connection, where we can pretty much be anywhere around the world and connect to our cluster or server. This brings us to high performance computing clusters. What makes them high performance? Right, they have um, specialized processors, upwards of 48 cores, some of them. The ones we have here at TSU have 32 cores. We also have GPUs for special tasks such as machine learning or doing simulations, molecular dynamic simulations. And so our cluster also has each node has 256 gigs of RAM, and then each one has well, they all share a 14 terabyte memory. And so when I said nodes, these are actual like individual, which you can think of computers that are kind of stacked on each other. And so we have one login node, and then we have 15 compute nodes. And you can connect remotely via the secure shell to each node. And so when we're accessing this, right, it's Linux based. It's actually Red Hat Linux distribution. And so it is a command line interface via terminal. We actually had a GUI installed as well for easier access for those who are not, as experienced with Linux. And it's called Open On Demand. And then so with this Open On Demand, you can actually have a virtual desktop, which just looks like your regular desktop. You can access RStudio, which is good for, doing statistics and making graphs. And then we can also access Jupyter Notebook, which runs Python. And so we don't actually have access right now, or you guys don't have access to the cluster because we're still working on the VPN. But you can actually practice the Linux commands and working on the terminal, the command line on your own machines. And so when I say local, this means right, you're actually working on your own laptop or desktop. You're not, you know, connected to the cluster or a remote server. And so for Windows, you can go to this website to download MOBA Xterm um, clients, and you'd want to download the installer version because there's two versions. There's a portable and an installer. And if you're on Mac, you don't have to download anything because you already have a built-in terminal. And so if you just search for terminal, and you should be able to open that program. And then so for MOBA Xterm, this is what the layout looks like. And so if you want to start a local terminal, you would just click this button right here, and it would take you to usually it's your home directory, on whatever operating system you have. But you can see down here there's some other, like this is a screenshot of mine. Um, we have BioRack, which is the TSU cluster. Then there's several others from the national labs that we're working with, the Department of Energy. And so, from this program, I can connect, to the national lab on the West Coast in Washington State, to the one in, wherever they're located, all across the United States, just, from here. And so when you're working in a Linux environment, it's basically everything's structured like a hierarchy of directories. If you want to think of it like folders in Windows or Mac. On the cluster, users have their own workspace. And so this is a little screenshot showing, pretty much all the users. Here's Dr. Idabu's, here's mine. But when we say path, we're talking about the location of the directory. We call it like the absolute path. And this can be known using the command pwd, which stands for path of working directory. And so if I'm in my directory and I type pwd, it's going to show me home and then, my home directory, where I'm currently at. And so a good thing, once you become more efficient and experienced with the command line, you can use the tab key to autocomplete commands, files, directories, and paths. Some common commands that everyone should know. LS, which stands for list, and so this will list the contents of your current working directory. CD stands for change directory. And so if I had a directory called directory one, I could do CD directory one, and then it would put me into directory one. If I want to go back like to my home directory, I could type CD dot dot, and then it's going to jump me back to the previous directory. And if you just type CD by itself, it will go to your home directory. If we want to make a new directory, we can type the mkdir command, which stands for make directory, and you would type make directory, and then followed by the name of the directory you want to create. And some more common commands. Say we have some files. If we want to copy a file, we can use the cp command, which stands for copy. And you know how this works is it would be copy file and then destination. And so if I want to copy my file that's in my home directory to directory one, I would do cp file one directory one, should be the destination. If I want to move the file entirely, it's similar to copy, but I would just use the mv command for move. If I wanted to remove a file or delete a file, it would be rm and then followed by the file name. Word of caution here, there is no undo in Linux, so once you remove it, it's gone. And so if we have, you know, say some files that have some text in it and we want to see the first few lines of it, we can type head and followed by the file name, and that will show us the first few lines. If we want to see the last few lines, we can use tail. And if we want to view a file one page at a time, say we have, you know, a file that's 100 pages long, we can use this command called less, which you know, doesn't open the whole file, but it will open one page at a time, and we can scroll down if we wanted to. Some other useful utilities or functions. There's grep, which you can use to search for a specific pattern in a file, such as a word, phrase, and it will print the lines containing them. And so if I'm, you know, I say I have a file of some mutation results, and I'm looking for just the gene TP53. You know, I can filter it out, and then this arrow means that it's gonna uh, port that to a new file that I created called TP53 mutations.txt. So it's just a quick way of kind of extracting certain lines from a file. If we want to look at specific columns, there's awk, AWK. And so here I'm taking um, column 2 and column 4 separated by tab from, say I have some docking results and I just want to get those, the second and fourth column. I can extract them, you know, using this syntax and, you know, create a new file with just those two columns called docking scores.txt. And if I needed to actually change text in a file, say like insert or remove, I can use the sed function. And so this will, in this example, I'm removing decimals and all the trailing numbers from some RNA-seq results that I have. And then again, I'm creating a new file that has, you know, those things removed. And so these, this syntax is kind of awkward, you know, just for sight. So it does take some getting used to. You know, there's always the manuals online that are well documented. There's also, you know, the community boards where people ask questions, how do I do this? And then, you know, more knowledgeable people will answer. And again, there's also Chat GPT, which has been trained on those, you know, all that stuff on the internet and could help you, you know, create some code that could do this easily. And so for shell scripting,
After class, I might go back to the student center.
there's an automated series of, which is an automated series of commands that reads like a script, right, line by line, and is executed. And we can create these in a text editor in the terminal, or you can do it on your computer and, you know, save it and then upload it to wherever you're working. Um, and so for a shell script, the first line is always going to be, if you're writing in Bash, it's going to be this line right here, which instructs the OS to use Bash as an interpreter for your script so it knows which language you're using. Um, and our file extension for a Bash script is .sh. So if I had a script, it would be like script.sh. And then, once I change the permissions to executable, I can just, pretty much type the script name. And this is basically saying um, execute the script. This is assuming you're in the directory that has the script present. Okay, and so this is an example of a shell script using a for loop. And so basically, I can, execute this um, in on the terminal, and it will go through, 20 of my files and create new files. And so on the cluster, if we have a lot of people, it gets crowded. Everyone's trying to, submit scripts. You can imagine it could get really hectic. And so we actually have a scheduler for that, which can allocate resources, nodes, um, cores if you don't need that much, processing power, or GPUs if you do need to use the GPUs. And so it has its own commands as well. So if you have a shell script called job.sh and you want to submit it to the scheduler, you would use this command sbatch followed by the script name. And we can check the queue of running and pending jobs if there are, using this command sq. If we just type it by itself, it's going to show us everyone's jobs that are running or pending. If you just want to look at your own job, you could just do sq-u and then your username. If you need to cancel a job, you can use this command scancel followed by the job ID, which you can find, in the queue. And you can only cancel your own jobs, thankfully. And so on the cluster, we have modules, which are software installed that everyone can access. The only thing is you have to load them first before you can actually use them. But you can check all the available modules using this line right here, module avail, and it will list all of the modules you can use. Once you find a module you need and you want to use it, you have to load it, and it's simply just module load followed by the module name. If you need to see which modules you've already had loaded, you can use this line right here, module list. It'll show everything that you have currently loaded and you can use. And like I said, you have to load these modules first to use them interactively, or you have to put this module load line in your script, so that when you execute your script, it will load the module first before it attempts to use it. And so this is a screenshot of some of the modules we have available. Some of the ones you will be using would be like Autodock for docking, ligands to receptors, Gromax and Amber for running molecular dynamic simulations. And so if there is a module you need and we don't have, we can get that installed as well. And so back to Open On Demand, which is our user-friendly GUI interface for accessing the cluster. Like I said, if you're not connected to the secure network here on campus, which is the TSU-net, you would have to be connected to the VPN first. And, I was talking to OIT and they said they would give you guys access and they would send you the instructions as well as how to install the VPN software and connect to it. But once you are connected to the VPN or you're on, one of our desktops here that's connected to the Ethernet, you can just simply type this address in your browser and you'll be you'll go to the open on demand where you have to sign in first. And so once I get everyone's approval for the VPN, I can start creating usernames for you guys. And then your default password is going to be usually it's your username and then dot change me. And we can go over how to change your password as well. And so once you sign in, you'll basically reach this web page. And if you wanted to get in, a Linux desktop, you would go to interactive apps and then hit Linux desktop and then choose how many cores you need, how much time you need. Please be, efficient with your time and use of cores. Don't, put if you're gonna an excess amount of time if you're not really gonna use it. And then once you hit launch, you'll be taken to this page where your job's gonna be queued for a few seconds. And when it's running, it'll say, which node it's on. So we have 15 nodes, right? So this one's on GPU 15, and each node has a GPU on it if you need to use the GPU. Right here it says it's running, and then so we can just click this button to launch the Linux desktop, and it's going to open up in a new window, and it's going to look like this, right? It just looks like a normal desktop, and we can click this button on the bottom that looks like a command prompt, and it'll open up a new window, and then here we can start entering commands. Um, and so if I wanted to see the contents of my home directory, I can type ls and it's going to show me, a few folders. So the folders are in blue. The actual files are in white. If I wanted to make a directory called Linux, I can use that make directory command and followed by the name of the directory I want to create, which is Linux. And if I type ls again after I've made that, it's going to show up right here in blue. So that's my new directory I just created. If I want to move into that directory, I can type the cd command followed by that new directory I want to go into. And then if I, check the path with the pwd command, it's going to show I'm in home brave.training, and then the last one would be the actual directory that I'm in, which is the Linux one. And so if I wanted to make a script, I can use the built-in text editor that we have. Um, a popular one for beginners is the Nano text editor. And so if you're on your local machine, you'll have to install it first using this command, apt install nano. It's take a couple minutes to install it. But once that is installed and ready to go, you can just type nano followed by the name of the file or script that you want to create. And so this is what the text editor nano looks like, right? Our file name is at the top. We have some, essential commands down here at the bottom. And so this little caret um, character is control. So if I wanted to exit, I would do control X. But first, I would like to add some lines to my shell script. So I'm going to put that first line that we always need for our bash uh, scripts in here, the pound sign, exclamation point, bin bash, which tells it where to look for the bash interpreter. And if I wanted to, this is just an example of, printing a hello world exclamation. And once I've done that, once I've got everything in my script that I want to that I need in it, I can save it. So write out basically means save. So I would do Control O, and it's gonna confirm that the name of the file is what I originally said it was. Um, and then I can just hit enter and it will actually save it. When it's saved, it will say it wrote 4 lines so that it wrote all the lines that you put in there. And to exit, you can type Control X, which will bring you back to the original um, prompt. And so if we want to execute the script that we just made, we would have to change the permissions of the file. And so this command, chmod, um, is how we would do that. And to give it execution permissions where we can actually run it, we would do +X. So chmod +X and then the name of our file. And you can, once if you do that, you can see that it changes to green, which means that it's able to be executed. And if I wanted to run that script, I could just type // and then the name of the script and hit enter. And then it's going to print out, I told it to print to this, this little saying hello world. And so it's going to print it directly out to the terminal. So what if our output is not just 1 line, say it's 1,000 lines? We can send that to a file instead of the terminal because really doesn't make sense to print out 1,000 lines to the terminal. And so here I'm showing how to do that. And in this example, the new script name is test loop. And so we're basically going to make a new file name called testloop.sh. And so in here, we're running a for loop where it's going to iterate, from 1 to 1,000. And it's going to print out hello world 1 to all the way to 1,000. And then it's going to keep adding it to this. So when I put two arrows like this, it's going to keep adding to that file that I've designated here, which is called hello.txt. And it's going to go through all the way to 1,000. And then when that's done, it's going to stop. And so again, I would, save this script, Control O, and then Control X to exit. And then once again, I need to give it permissions so that it can be executed. And I'm gonna to run the script, I'm gonna do the same thing, right? / and then the name of the script. And but this time the output is actually, a file that I created. And so if I look at the file using the head and tail commands, I can see that, this would be the head command. It's going to give me the first 10 lines, and then tail, the last 10, showing that it went all the way to 1,000. And so what if our script, takes a long time to run, which, when you start doing simulations, they can take hours to days to run. And so this is where the job scheduler Slurm would come in handy. And we can submit a job in the form of a batch script to the job scheduler Slurm. And so here I'm making a shell script titled test loop batch.sh using the same nano text editor. And so here it's a little different if we're going to be submitting it to Slurm. We'll need to put these lines in here that we are telling it what the job name is. So when we look at the queue, it's going to show this as the job name, hello. And then I can also tell it to make an out file if there are errors encountered, and it will actually create a file. And if there are errors, it's going to print to that file. If not, it's just going to be an empty file, but it's still going to make it. And so here I'm doing the for loop again, but I'm going to 1,000,000 instead of 1,000. And so this one, is the same format as the previous one, going to 1,000. With this one, it's going to take a couple minutes to run. And so again, give it permissions, submit the script using the sbatch function. And while it's running, I can check the queue to make sure that it is actually running. And so that script is this one right here, which remember I said the name, we gave it hello. And right, says which node it's on, GPU 15, how many nodes. This is the time elapsed. So it's only been running for 1 second when I checked on it on this one. And that's it. I really wanted y'all to do this, in real time with me, but we haven't gotten the VPN access yet. But you can still, if you're on Windows, download the MOBA Xterm to practice the Linux commands. If you're on Mac, just open the terminal and practice some of these commands. I can share this PowerPoint with you so you can go through it. The simple scripts you can practice on your own and run on your own computer, but if you're submitting to, the Slurm scheduler, you're going to need the cluster to do that.
All
Okay.
right, thank you, Dr. Scott. Thank you.
Mm-hmm.
What I'm thinking is, I think what you did, I really like the way you put it, but I want you to probably have a kind of live demonstration of some of these things for them
Mm-hmm.
to see how it works. Yeah, I like the way you have a sequence picture of how it used to be, but I would like them to see. I don't know if you can log into and share your login process to the cluster where you are. Then I think many of them are also on campus now. I think some of them are on campus. At least if they're on campus, then they don't need VPN. If you're on campus, you don't need VPN. But if you are at your residence, that's when you need VPN. So if you're on
Okay.
campus, Dr. Scott can show you how to log into this. You already generate the username and password, right?
No, I'm waiting on the VPN because I was looking at some of them have it looks like some people have TSU regular emails, not the student emails, which
Oh,
was surprising. So
oh,
like Alaya seems to have um a regular email. So I don't want to make another
no,
um
Alia, send your TSU email. Everybody because you can only log in with your TSU email. Please share your
Oh,
TSU email with Dr. Scott.
should I send it in the chat or in an email? I can send
Just
it
send
right.
it to him in email.
Okay.
like
Yeah.
Binaj. She
Binary
she has it looks like she has a regular email as
regular
well.
email.
So
No,
I'm not sure how that happened. Maybe they're workers,
no,
student workers or something.
I think so. You
But
just
I don't
send your student's email to Dr. Scott. Then who is taking our attendance? Is it Alia or who? Alia, are you the one taking attendance?
Um, Yeah, but I don't really know how many people.
We're
Like,
supposed you guys are supposed to be 6 students.
okay,
Yeah. So please always take note of everybody.
okay, every week. Okay.
Yeah. At least if you're not meeting up to 70% attendance, you are not due for the second batch of the payment. That's what I want to do.
Okay.
I want everybody to be involved in this.
So do I take attendance and send you the names of people every week?
Just keep it with you for now. I can request for it from you anytime.
Okay.
Yeah. I can request for you request for it from you anytime. All right.
Mm.
So Dr. Scott, I think you can probably share your screen and probably log in. Let them just see that. Log in and
Okay.
probably do some of the few learner stuff. Let's round up in the next 10-15 minutes
From
because of our meeting.
okay. Yeah, so I didn't want to make everyone's usernames because I wasn't sure, if I overwrite somebody's that already has an account, it gets complicated.
Yeah, I
So I'm
understand.
gonna wait till the OIT contacts me about that. But yeah, so if you're on campus, again, you'll have to be connected to the secure network, which, if you're in a computer lab, those are connected. Um, but if you're just on the student Wi-Fi, it won't let you access. And so here, I'm gonna incognito tab, um, or window because it's easier to log out. It clears all the cookies and the cache. But if I just type biorack
.tsu.edu.
edu, that's all you need to type.
That's what you need, just barrack.tsu.edu. It's going to give you, so Dr. Scott is going to create your
Yeah, then
username
just yeah.
and your password for you.
And then this little dialog pops up. Brave.training. Uh, and yeah, and so I'm here. If I want to access the command line, I can just go to this clusters right here, to access, and it brings me to my home directory. And so here's remember the blue, whatever's shown in blue is going to be your directories or folders, and the white would be just a regular file. And so if I wanted to let's just look at that one file there, that hep.sdf. um, and then see, I don't even have to type the whole thing. I can just type HEP and then tab and it will complete. So that's makes it pretty efficient. Um, yeah, and so this is giving me like the first page since I used the less command. And so this is actually like a chemical structure. And if I wanted to get out of that, I can just hit the Q button, for quit. It'll quickly exit out. If I want to go to Linux, CD Linux, and now I'm in, right here it shows that I'm in that's the current work directory that I'm in. Um, let's see what's in there. There's all my scripts, right in green because I changed the permissions. Then the other ones are my outputs. Yeah, and if I wanted to edit one of those scripts, I could just use my nano text editor, and here I am. And so I just edit it. I added another line, and so I need to save it again. So Control O, just confirming here that that's the name of my file at the bottom. And so I hit Enter. And to get out of the text editor, I'm going to hit Control X, and it's going to go back. And if I wanted to run that file again, let me see, now I have my new hi again line here that I added to it. And if I want to check the queue, I can do SQ. Right now, nobody's running anything. So it's empty. But if I go to an interactive app here, so let's say I want a Linux desktop, right? Let's say I don't really need a GPU. I just need 4 cores, only an hour. And it's going to um, take a little bit to get started. And there you go. I'm on GPU 15. And I'm going to launch that. Let's see if I can move this. And I'll just allow copy paste because it's easier. And now if I check the queue, you can see, oh, looks like somebody else is on now. Dr. Idowu. But there's me, the one I just started, right? And then there's Dr. Idowu jumped on too. So we're actually sharing the same node here, right? We're both on GPU 15. That's okay. It it can handle that. But if we requested the whole 32 cores in a GPU, then we would get that whole node to ourselves because we can't share if we've asked for all of it. Yeah, if I wanted to, load a module, let's say I want to load this Chimera X, which we were looking at last week. No errors, right? That's good. And so just type this, and yeah, it pops up, right? It just looks just like my laptop or desktop. And it's not as, I mean, it's pretty good as far as the lag because you're on another computer far away, but this is pretty good. Yeah, I can pretty much do everything I can um on my desktop. Say I wanted to open another file. There's actually the thing I just opened, it's way over here. But yeah, it's a small molecule compound. Yeah, I can it's pretty much like I'm on my desktop. And but I've got the power of the cluster, 32 cores, 256 gigs of RAM, and a GPU if I
Oh,
need
the
it.
camera X now work on the cluster now.
Yes, yeah.
Great.
And yeah. And so yeah, the Linux application, the Linux desktop is good for things like this, where we need the GUI, right? The graphical user interface. Um, let's see, like there's another program called VMD, which is similar to Chimera, has a little, it's more in for the dynamic simulations, right? We can do some modeling, we can analyze results, create graphs and stuff like that. Um, and um, and so we also have Jupyter Notebook, right? That's for Python. And then we also have RStudio as well. And so this is what Jupyter Notebook looks like. I don't think I have anything. I don't have any notebooks, but if I wanted to create a new one, I would just go new Python 3. And, this is basically Python, um, you know, import pandas, is a common library. Yeah. And for R, it's more of it's RStudio, so it's more of a GUI, more of a user interface. Let me just show you this one. Right, and so this is R Studio. I don't know if anybody's ever used R. But here, I can plot, I can look at my packages. Yeah, and so we've tried to make it where you can do anything you can do on your laptop or desktop, you can do on the cluster, and you're just in a supercharged way because you have the high performance computing hardware. And yeah. And so once you guys get once we get the usernames figured out and the VPN access, you'll have access to all of this. And to exit out of the Jupyter Notebook and R, I can just close them. But they're gonna still be running, and so if I'm done, right, I'm not gonna use them anymore. I can just hit delete, and it will delete my session and free up those resources. Let's see. It should go. Yeah. And so I deleted my session, so then it no longer shows mine on there. Okay.
All right, thank you, Dr. Scott.
Mm-hmm.
Yeah, I think next week we still going to do a little more of that Linux demonstration for them to understand better.
Yeah.
So, if you have Mac, just go to your Mac and open Terminal. You can play with the Python script. So Dr. Scott is going to share that slide with everybody. You can use that, and if you encounter any problem, please feel free to talk to me. Message Dr. Scott and I. We will be able to provide answers to your questions. Any questions for today? Do we have any question?
I think it'll be pretty self-explanatory once we actually do it as a group, but just seeing it for the first time, I'm pretty sure I'm not the only one who's like, what is this? But it seems pretty not like too hard or too complicated. I think it's just that we just kind of need to go through it as a group.
Yeah.
Yeah.
Another thing is you don't have to wait for a group. I'm going to upload this video. I have a meeting in the next couple of minutes now. So I will upload the videos. You can probably watch the videos over again. So next week, Dr. Scott will also take you through some tutorial add-on tutorial on Linux, how to create folder, how to move from one directory to another directory, and all those many stuff, at least the basic stuff that you need for now. I think that you will need for our MD simulation, that we need for molecular docking and some other stuff we'll be doing right now. So I will advise you, at least before the next meeting, watch the videos for the previous meeting twice before the next meeting. So we are going to dedicate probably the first 10 minutes of every meeting to question on the previous videos. But if you have not done it, practice it yourself. There is no way you will be there's no way you will be able to ask a reasonable question. This is volatile. Let me be sincere with you. It is highly volatile. If you do not practice it, they are easy to forget. As simple as that. All right. Okay. So please let me know September 10 and 11 if you're going to be available. I encourage you to be available. We are going to learn a lot about opportunity for TSU students under the Department of U.S. Navy Department. I'm sure we have one or two things that can benefit to your academics and to your career in the future. All right. If there is no question, I want to say thank you to everyone, please.
Okay, you're